Okay, this is the practice problem video for 7.1 Pythagorean theorem. So let's go through some of these practice problems together. For 1 through 4, we're just finding the length of the missing side. Let's write out our Pythagorean theorem up top. A squared plus b squared is equal to c squared, and c has to be the hypotenuse, or the longest side. All right, it's also always across from the right angle, okay? So let's just go with number 1 here. So x has to be our c squared, so let's call this a and this b. So 12 squared plus 5 squared is equal to x squared. All right, so now we can just square these out. 12 squared is just 12 times 12, which is 144. 5 squared is 25. Now we add them together, and we get 169 is equal to x squared. And so if we want to solve for a single x, we do the opposite. The opposite of squaring something is taking the square root. So the square root of x squared is x, and the square root of 169 is 13. So x is equal to 13. Okay, looks like all of those you're finding the hypotenuse. So it looks like for all of these you're looking to find the c squared term, okay? 5 through 7 looks like we're finding one of the other legs. So for 5, we're going to call this one C. A and B doesn't matter. I'm going to make this A and this B. Okay, so let's write this out as 11 squared is equal to 9 squared plus x squared. All right, so let's first square these out. 11 squared is 121. 9 squared is 81. That's a bad 8. Try that again. 81 plus x squared. Right, we want to isolate x. So let's get this x squared, or this 81, out of here. We do so by subtracting on both sides. And we're left with 40 is equal to x squared. And now we take the square root of both sides. Let's see, what's the direction say? Leave the answer in simplest radical form. Let's go ahead. So I know the square root of x squared is just x. All right, so let's go to the calculator and find the square root of 40. Remember, we need to hit the second key to access this green radicand. That's the square root symbol. Oops, see, I didn't do it right. Second, there we go. That's what we're looking for. Type in 40, press enter, and that is simplest radical form, 2 times the square root of 10. All right, and that is your answer. That is in simplest radical form. If you need to find the decimal equivalent, you can just hit these double arrow keys, this left and right key, and that will give you the decimal equivalent. So that would be 6.32455. Okay, moving on. State if the 3 lengths form a right triangle. So basically, we're just making sure that the 2 smaller lengths add up to the square of the longest side. So this is going to be A, B, and C. So we're going to do 6 squared plus 8. Whoops. 8 squared is equal to 12 squared. All right. And so if these don't equal each other, it's not going to work out. 6 squared is 36. 8 squared is 64. And 12 squared is 144. Add these up, that's 100. 100 is not equal to 144, so no, this is not a right triangle. All right, so if you get them to equal each other, that would be a right triangle. All right, so now we're stating if the triangle is acute, obtuse, or right. So again, so if c squared is greater than a squared plus b squared, well then it's going to be obtuse. If c squared is less than a squared plus b squared, then it's going to be acute. All right, so let's go. I'm going to switch around. Let's do how about number 14. Again, the longest side has to be the c term, so the others don't matter. We'll do a and b. So a squared, we'll do 3 squared plus 12 squared is equal to 13 squared. And we'll square them out. We get 9 plus 144 is equal to 169. I guess I should show you guys. You can use your calculator to square these. If I want to square 13, you can just do 13 and then hit this x squared button. All right, that's one way. Or if you want to raise it up to a different power, you could always go 13 and hit this little arrow up looking thing, and then you can put whatever power you want. But because we're squaring, we'll do 2, press enter, we get the same answer. All right, back to this one here. 9 plus 144 is 153. 169 is here. The mouth wants to eat the bigger number, so that means the c squared term is greater than a and b squared. So this is an obtuse triangle. All right, moving on. All right, leave and simplest. This is the application and extension problems. Number 1 and 2 look pretty similar. You guys can do those. How about I do number 3 for you, or we'll go through it together. All right, the algebra softball team had tryouts last weekend, and Mr. Brust wanted to play catcher. Mr. Kelly started laughing and said that there was no way Mr. Brust could throw the ball from home to second base to catch someone stealing. Okay, if the baseball diamond is a square, the length of the sides is 90 feet, then how far does Mr. Brust need to be able to throw the ball? Okay, so if you don't know anything about baseball, the catcher stands right here. And if there's a guy on first, he can try to run to second base, but this catcher is going to throw the ball and try to get him out before he gets there. So we're looking at how far this catcher would need to throw. All right, if we know it's a square, so all of these are 90, but we need to find this length, okay? And so we know that we've got 2 different triangles here. So basically what we're doing is we're trying to find the hypotenuse of like this triangle here. Doesn't really matter, but either one. Okay, so we're going to find this length. So we're going to square both of these and figure out what this distance is. So we're going to do 90 squared plus 90 squared is equal to x squared. Okay, so let's square them out. 90 squared is 810. 90 squared again, 810 is equal to x squared. Add them together. What do we get? 1620. Put x squared. And now we take the square root of 1620. 1620. Oops, what am I doing? Clear that out. I gotta hit that second key first. Get the square root symbol. Now we can put in 1620. And it looks like that is going to be 40.24. We'll just call that 40.2 feet. I should label it feet is what x is. So the distance of x is 40.2 feet. All right. Number 4. I'm going to have you guys do this one, but I'll kind of set up the picture for you. Mr. Kelly has a huge wall that is 16 feet tall, built around his entire backyard. One day he locks himself out and realizes he has to clear the wall. He has a 17-foot ladder, so he feels though it should be a piece of cake. When he takes the ladder over, he realizes that the closest he can get the ladder is 10 feet from the wall because of some shrubs. Okay, so let's start out with, so he's got to get over this wall that's 16 feet, and he's got a 17-foot ladder, but there's some shrubs here. Okay, here's the shrubs. And the shrubs go from the wall out 10 feet. Okay, so here's kind of a triangle that we're setting up. Now he's got this 17-foot ladder, right? But we don't know if he puts the ladder here, is he going to be able to make it or not? I don't know. Oops, I didn't like that. Clear that out. Okay, here's 17 feet. Here's the 7 or 16. Stop doing that. There we go. All right. 16 feet is here. Try this again. 17-foot ladder. We're not sure if this is going to be long enough. So what you're trying to figure out, you have A, you need to find B, and here is C. 16 is kind of irrelevant. We're just looking to see if this height, B, is going to be 16 or higher. If it's not, he's not going to make it. Okay, I'll leave the rest for you.